Hello everybody, my name is Mr. Peter, and today we're going to be learning about algebra tiles. So, before we can actually do anything fancy with algebra tiles, we first have to know how to read them. So, algebra tiles, in this case also known as area tiles, are just a way of representing variables and expressions. So, let's actually first observe what the area of this box over here is. If you just notice, the area of this box, I'm just going to shade it in right now, is going to be its length times width, which is just in this case 1. Over here we have a box with length x and a width of 1, actually a length of 1 and a width of x, which is just going to have an area of 1 times x, which is just x. Over here we have a giant looking box which has a length and width of x. So therefore, the area of this giant box over here is going to be x squared. Now, something you might want to know is that sometimes we refer to these small boxes as smalls, these long boxes as longs, and these just regular looking square boxes as boxes. So just keep that in mind. I might use the term willy-nilly now and then, but let's actually try solving some problems using this now. So, right over here, we have one example that says to multiply using the area method. So we have this expression, x plus 2 times x plus 3. So the way you can actually model this right here is to actually just write this out literally using the areas we found earlier. So if you just notice over here, we have a regular small looking box representing a 1 and a long looking box representing an x. So going back over here, x plus 2, well, x is just a long looking rectangle box, right? With the dimensions of x and 1. And then 2 is just, well, we're not going to write a length or a width of 2. Instead, what we're going to do is we're going to actually show 2 by writing two 1 boxes. So the areas of each of these is x, 1, and 1. And 1 plus 1 is 2. So now we've represented x plus 2 using the algebra tiles or area model. Let's actually now represent x plus 1 using the same method. So let's actually write it right over here. We now have a long strip representing the x tile right over here. And we just have a small box representing the 1. So if you're wondering what you're going to now do with all these numbers and everything, well, you're actually just going to fill in the area. So if you notice right over here, this giant box has a length or a width of x, and this giant long strip actually has a length of x. Combining those two together, the length of x with the width of this other x is going to give you a box with the area of x squared. You can now apply that same concept over here. We have a width of 1 combining with the length of x, combining those two together, and you'll get a long strip with an area of x. Now, you might be acquainted to this method of doing things now, so I'm going to work a little bit faster. Length of x, width of 1. You'll get a long strip with length of x. Same thing over here. Width of 1, length of x. And we'll have another area of just x. Now, on to the 1s. We have a width of 1. I'm going to also draw one over here. and a length of 1. Therefore, the area of this giant thing is now going to be just 1. And 1 respectfully over here. Now, what drawing all of these areas actually does is it does all of the calculations for us. So the answer to x plus 2 times x plus 1 is just this. We have a single x squared and 1, 2, 3 x's. 3 x's and 2 1's, which is just 2. So the answer is x squared plus 3x plus 2. Okay, so anyways, for number 3, we're actually just going to have you try this on your own. So anyways, I'll give you a few seconds to do that if you haven't already. But feel free to pause the video, or even don't pause if you just want to enjoy the show. So I'll give you 5 more seconds or so, and now let's continue. So again, I'm going to highlight both of these, and I'm going to use this first part for my width. So we have 1x, which is going to be one long strip with an area of x, and 3 smalls with an area of 1. 3 smalls. There we go. And now we're going to take the lengths. So we have 1 long x strip right over here. 1 long x strip. And looks like 2 smalls. 2 smalls. Just scroll down a little bit. We have 2 smalls. 2 small ones. Now we just have to take the area of each of these, and I'm going to skip past a little bit of this, but it has a width of x right here, length of x. Make sure you can just kind of notice that, oh, we're just taking this long green side right here and attaching it right over here, and so on. Taking this long red strip over here, attaching it right here. So make sure you can notice that. This is going to make it an x squared. Kind of speeding up a little bit. This one's going to have a width of 1, length of x, gives you an x. Same thing right here. All of them should have the same length. And right here, all of them should have the same width. Actually, let me just also highlight this in, just in case anybody's confused on where that came from. Okay. All of these right here have the same width of just x. So let me just highlight that in too, just so that you know where it came from. Therefore, all of these are going to have an area of x. Let's keep going. You're going to get, let's see, a square right here. Just follow it downwards and to the side. Area right here, 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 and here. So 1, 1, 1, 1, 1, and 1. So make sure you know where all this came from. So this right here, you just notice, or actually, oh, not quite. The length part of it came from whatever is to the left, right over here. This controls the length part. Anything on top controls the width. So that's where all the widths came from. Just keep that in mind. Keep that in mind. Okay, but anyways, we can now just start counting everything up. Right here, we have a giant x squared. We have 1x squared. Count all these up. We have 1, 2, 3, 4, 5 x strips. We have 1, 2, 3, 4, 5, 6 ones. Therefore, our answer to this original problem is going to be x squared plus 5x plus 6. And now for the last one over here, I just want you to think of, before we end everything off, how can we use algebra tiles to multiply this right here? So this is x minus 2 times x plus 3. How can we still use algebra tiles to multiply these two together? Now, it might be a little bit difficult to understand or even see, but you might be able to come up with something on your own. So anyways, that's going to be all for today, but I hope you have a good one.